excuse me. Alright guys, so we're at our last video for our last concept for this course. It is about graphing inequalities. Alright, so a couple of things. I'll never have this ready. I don't know why I've not learned my lesson. When it okay, this guy right here is less than. Here, he is greater than. This is less than. And then you've got the line right there. So it's or equal to. Oops. And so he is greater than or equal to. Okay? If you're a step person, these are the steps we're going to follow. We're going to graph a line as normal. We're going to determine if it's a dotted or solid line. Kind of like before, if it was like an open circle or a closed circle. We're going to test a point. The point we normally test is 0, 0. And then we're going to shade where it's true. I'm going to show you what it means. Okay, unlike when we just graph here and we just like shade this way, or maybe we shaded this way. Unlike that, where the inequality like points where to share, unlike that, it doesn't tell you where to share. You have to test the point. It doesn't tell you where to shade. I think I said share. Okay, so the first step is graph the line as normal. So here we are. It's in standard form. So first I'm going to figure out the x-intercept. So I'm going to do the x, and I'm going to figure out the y-intercept. Excuse me. And so when I figure out the x-intercept, I'm going to substitute 0 for y. And so that's why I have just this 3x equals negative 15. And I'm going to divide by 3. So I get x equals negative 5. So my x-intercept is negative 5, comma 0. My y-intercept is when x is 0. So that's why the x disappeared. I'm going to divide by negative 5. So I get y equals 3. So I get 0, 3. Stop. Come on, computer. It's like, no, it's a Sunday. Alright, this guy is got an equal to. So because it's an equal to, it is solid. If it was not equal to, I would have done a dotted line. I'll do a dotted line in a few minutes. So now we need to test a point. And so what I mean by test a point is, okay, I'm going to do 3. I'm going to test 0, 0. I'm going to plug in the 0, minus 5. Plug in the 0, greater than or equal to negative 15. So that's a 0. 5 times 0 is 0, greater than or equal to negative 15. Alright, well 0 is 0, 0. Okay, 0 is not greater than or equal to negative 15. 0, 0 is right here. That is not a true statement. Because that's not a true statement, we're going to shade where it is true. So this is where it's true, over there. Okay, so what we're doing is, hang on. Sorry, I have the sneezes today. Okay, what we're going to do is, or what we did is, instead of just saying like, hey, what is the line that satisfies this and what are just the coordinate pairs? This says what area. So this inequality does not say shade everything to the left. Okay, we didn't shade to the left. We actually shaded to the right. Okay, because we tested a point and figured out where it was quote unquote true. And so what's true is everything on this line plus anything up here. All right, let's do another one. Okay, let's do this guy. He's also in standard form. We're going to do the x and y. My mind just went totally blank. Intercepts. I don't know why my mind like. Okay, x-intercept is when y equals 0. So that's what we have left. Y-intercept is when x equals 0. Okay, but you can't have a negative x, so we're going to divide by -1. So our coordinate is going to be 5. 5. Can't have a negative y, so we're going to divide by -1. 5. Okay, this is not an equal to. Okay, so that means that it cannot equal any of the coordinates on that line right there. Right now, so we did those two. Now we have to test a point. So I'm going to test 0, 0. -0 minus 0 less than -5. Well, 0 less than -5. $0 is actually greater than -5. 0 is right here. And so that's not true because 0 is not less than -5. It's greater than. So I'm going to shade everything over here. It just happens. So our answer for this is not the ordered pairs on the line, but anything in the shaded area. Let's do another one. All right, so here we are. Our y-intercept, remember our y-intercept is b, -2. So he's right here. And then we take our slope, so it's the number touching x, so it's 1. So that means we're going to go up 1, right 1. And you always make it a fraction, so that's why I did over 1. So up 1, right 1. Up 1, right 1. And it's not equal to, so it's a dotted line. Put arrows on it. Okay, now I need to test a point. So I'm going to write 0 less than 0 minus 2. So 0 less than -2. 0 is not less than -2. If you have $0, you actually have more money than somebody who owes you $2. Okay, 0 is right here, so I'm going to shade where it is true. So it's all this. Okay. Maybe you're getting a little bit of hang of it. Let's do another one. So here we are. This one's written not quite what you're used to, which is why I did it. This is really like -1/2 x plus 3. So the y-intercept is 3, and the slope is -1/2. So the y-intercept is 3, so we put a dot at 3, and the slope is -1/2. So that means we're going to go down 1, right 2. So from that point, we're going to go down 1, right 2. Down 1, right 2. And he is equal to, whoopsies. All right, pretend it goes through those points. All right, now we need to test 0, 0. All right, 0 less than or equal to -1/2 0 plus 3. All right, and I got this from right here. I just had rewritten it. All right, 0 less than or equal to -1/2 times 0 is 0 plus 3. So is 0 less than or equal to 3? Yes. All right, 0, 0 is right here. So we're going to shade everything over here. All right, so this means that any answer that is on this line, because it's solid, or any answer, when I mean answer, I mean ordered pair, or any ordered pair that's in that shading is the correct answer. All right, what about here? This guy is the same as saying y is less than or equal to 1x plus 0. All right, so our slope is 1 and our y-intercept is 0. So our y-intercept is 0 and our slope is 1. So we go up 1 over 1, and it is equal to. All right, we cannot test 0, 0 because the line is on 0, 0. So let's test any other random point. I don't know. Let's test -5, -5. I just did something random. 1, 2, 3, 4, 5. All right, that's right here. All right, so I'm going to do -5 less than or equal to -5. That's a yes because they're equal. So that's a yes. Let's test, I don't know, -5, -3. All right, so the y is -5 less than or equal to -5. So -3 is it less than or equal to -5? So let's, -5. Oh, hang on, guys. This is not -5, 5. This 1, 2, 3, 4, 5. 1, 2. This is -5, 5. Silly girl. It's on the line. All right, let's test -3, 5. -5, -3. I was doing the opposite. All right, there's -5, -3 right here. All right, -3 is not less than -5. It's actually greater. So we aren't going to shade where that point is. We're going to shade the opposite. Okay. That was kind of tricky, but I wanted to show you that we don't always use 0, 0. If the line is actually on 0, 0, we can't use it. But 95% of the time, we're going to use 0, 0. All right, x equals 2 is, okay, so, and it's a solid line because it's equal to, so here we are. And then let's pick any number for x. I don't know, 7. So is 7 less than or equal to 2? No. Right, 7 is like right here. All right, 7's not equal to 2, so we're going to shade over here. So it's a vertical line. All right, let's try this one. Y equals -4. Oh, and he's solid too. 4, -1, 4. Solid line. Pretend that, oh my god, pretend that's like a straight line and it goes through 4. That's awful, guys. Okay, and let's pick any random number for y. Let's pick, I don't know, -1. Is -1 greater than or equal to -4? Yes. And -1's right here. So we're going to shade all of this. These are a horizontal line, by the way. All right, and that is graphing inequalities. I will talk to you later. Bye.